Welcome everyone to Insights Over Access, confined space drone-enabled inspections of complex critical infrastructure. Just a reminder that we will be answering your questions at the end of the webinar, so we encourage you to enter them in advance by clicking the Q&A button at the bottom of the webinar window and typing in your questions. Feel free to do this before, during, or after the main presentation. If we're unable to answer your question today, we'll be happy to connect with you after the program. Also, this presentation will be recorded and made available to everyone who registered. We're joined here today with Frank J. Segarra, Chief Revenue Officer at Skyladder Drones, a nationwide commercial drone services provider, including confined space inspections. Also joining us is Taylor Wilson, Area Sales Manager at Flyability, the company that makes the Helios 3, the first indoor mapping and inspection drone. And now I'd like to turn it over to Frank Segarra.
Thank you, Martin. Thank you. Good morning and welcome, everyone. And thank you for joining Skyladder Drones webinar, Insights Over Access. It is my very pleasure to have you with us today. I'm especially honored to welcome Taylor Wilson from Flyability, a friend of mine. Taylor, we appreciate you joining. How are you today?
Frank, good morning, everybody. I am doing fantastic. It's great to be here, to be on the webinar and to see you guys. I really hope that, some of the things that we're discussing today is insightful for everybody and that you guys see some value in it. Thrilled to be here, everyone.
Thank you, Taylor. That is great. And before we dive in, for those of you on the line who might not be familiar with Flyability, Taylor, what's been your focus recently working with Flyability and more specifically with the Helios 3 platform?
Absolutely. Great question, guys. My name's Taylor. I'm an area sales manager for Flyability. So, basically what I specialize in is the commercial development of our confined space solutions using our Helios 3 drone. I'm extremely passionate about this space. I love to, show the market our differentiated solutions that are designed to help keep people out of harm's way. So, that's one of the main focuses that I bring to the table. When I'm not at work and doing things like that, I'm in Denver, Colorado area. So if you guys may see me skiing or on some hiking trails out here, but keeping people safe and getting insights out of challenging spaces is what I do every day. So excited to be here, sir.
And Taylor, what do you think is driving the adoption of confined space UAV flights, primarily in the critical infrastructure space?
Yeah, I think the tipping point really happened a couple of years ago where like the hardware and software really got to the point where these types of flights were safe enough to do. And that, the sensors that were on board these things were developed to the point where the data quality was good enough to get actual, that data, the information, the insight, step process. So I think, once we got into a couple of the markets that were seeing the value on it, we were able to expand some of the use cases in the different areas. That's really what we hope to keep developing. So everybody that can keep out of a confined space is kept out of the confined space.
Outstanding. Excellent. Well, Taylor, we'll be touching back and forth during the course of this presentation, and I'm going to talk briefly. Before we get started, let me walk you through what we're going to learn in today's session. We'll begin by defining what inspection grade aerial data actually means in confined space environments and why distinction matters for engineering and asset management teams. Applications of the critical infrastructure. Obviously, there are hundreds of different applications that will fit the critical infrastructure space. We're going to talk about a handful. We could talk for hours about every one, but we're going to talk about the ones that we see are really very dominant. Then obviously we're going to get into the Helios 3 confined space platform, the drone platform, UAV platform, which is what we are currently using for all of our national confined space projects around the country. And we're going to talk about how to reduce the outage duration, because the outage duration is really, that's where the client really becomes concerned with manual inspections as well as UAV inspections, because some of them may not be familiar with how quick and efficient the UAV actually is during an inspection. So we're going to talk about the outages and the concerns that come with that. Then we're going to talk about the methods for improving defect detectability. So, you can fly a drone into a space and just take images and video and just fly all over the place. But there are certain methodologies that will allow you to get much better defect information, the anomaly information, to make it more engineering friendly. And then we're going to talk about structured reporting and how regulatory, FAA regulatory, as well as OSHA regulatory rules and regulations will definitely need to be concerned. And then lastly, we're going to talk about how 3D capture actually enhances the remediation planning for folks that are looking to do remediation on these spaces. Some of the remediation is by compliance. Some of the remediation might be because of an emergency situation. Like we're often called, because there's a leak somewhere and they can't figure out where the leak is. So we'll come in, we'll do the inspection, and that's an emergency type of situation, even if they're meeting their compliance requirements. And then lastly, I'd like to say to everyone, please stay with us to the end of the presentation for an opportunity to win a cash prize. I'm not going to let everyone know what that cash prize and what it is that we're going to do at the end, but if you can just stick around, the webinar is scheduled for an hour. Somebody will win a cash prize at the end of this. Okay, so before we get into specifics, some of the key challenges that come with the traditional infrastructure inspection is number one, the pressure to minimize the operational downtime. We talked just the last slide about operational downtime. If you think about some of these large factories and these large chemical refineries, to put several systems out of service, even for a few days, is quite an expensive proposition. So our clients really want to figure out how to minimize that downtime so they don't lose profit. Then we have aging infrastructure, which, the infrastructure is what we see, but we don't know what we're seeing until we're actually in the space. So if something is aging and it's collapsing and it's falling apart, we're going to find out pretty quickly without putting a human being in the way. And regulatory scrutiny, obviously, with OSHA, if it's been required by OSHA that a human can't enter the space, it's a confined space, which most confined spaces need to be surveyed before a human can go in. Limited access to the actual critical structural components. Some components could be 10 feet long. Some components could be 10 centimeters. Depending on where it is and what it is, there's limited access to those components when you're manually inspecting. And many inspection programs still rely on the good old-fashioned manual inspection method. Now, to give you some context, a manual inspection, for instance, for a petroleum tank, well, the first thing they have to do is once the tank is cleaned, they have to build a scaffold. They have to make sure that there are no toxic gases inside, no flammable gases inside. So there's a lot of weeks of scaffolding and work that are involved in getting that manual methodology kind of in place before they even put a human in. Many of those methodologies don't even need to be done if you're going in with an autonomous vehicle. And that's why they're seeing huge value in this today. So let's talk about the limitations of traditional inspections. So obviously, confined space, you could either traditionally climb inside the space, you can ladder inside the space, you can you can get into the space however you can get into space. Sometimes it's on your belly and you're crawling in, and sometimes there's residual debris and water and glass and all sorts of things that are in there. So there are advantages because you can navigate the spaces impractical for drones. like I said, with the small componentry that you might need to inspect that you can't even get to with the drone. That's an advantage. Um, and with the human, it allows us to detect pathologies that drones might miss. And when I talk about pathologies, I'm talking about chemicals and gases that may not be obvious to the drone, especially if we don't have a gas sensor on the drone itself. The pathologies will be collected from the subject matter experts inside these inspection tunnels, sinkholes, whatever it is. And those pathologies will be identified. And we certainly wouldn't want people, getting cancer or getting a caustic material on their skin could dramatically affect things. So let's talk about the actual applications. We talked about a bunch of applications earlier, hundreds of applications, but we're going to talk about just a handful here. So some of the obvious are energy infrastructure. Energy infrastructure could be a combination of power generation, oil and gas, pipeline systems. In transportation, we have bridges, the whole transportation network system anywhere becomes a transportation asset, and many of those assets are in confined situations. We have railroads. Railroads will typically go underground, and where they're not going underground, a lot of times they're out of an area where you can get a human in to inspect in detail. So there'll be a small shutdown for a drone, and same thing with tunnels. Tunnels can be active tunnels, or they could be decommissioned tunnels or collapsed tunnels. There's a whole slew of different tunnel situations that you can utilize a confined space drone. And then we have wastewater and water in general. We have sewer systems, sewer networks, and essentially treatment plants, stormwater systems, systems that rely on the water either being a source of energy or the water being a source of basically, living. It could be treatment plants, and treatment plants are important to human survival, obviously. Then we have industrial facilities, which, chemical staging, processing vessels, containment structures. These are all different critical infrastructure type of applications. And you can obviously see by looking at a lot of the images where the value stands in seeing the data and the information inside from both an RGB perspective as well as an infrared and or a LiDAR point cloud. So some of the advantages from a safety perspective, super obvious. I can't list them all, but the advantages are number one advantage is eliminating the need for an actual human to enter this hazardous atmosphere. And what I said earlier, you have various types of elements and compounds. You have hydrogen sulfide, you have methane, you have combustible gases. It might be even low oxygen atmosphere, toxic industrial vapors. These types of things are not going to affect, 99% of the time, not going to affect the drone that's doing the inspection. Then we have removing the fall and vertical access risk. If we're going down and we're traversing down a sewer, sometimes to get into the sewer initially, we have to go down a manhole. And we've been down with the drone down 50-foot manholes that have ladder components that are very rusted, unstable. And a human actually has to climb down, good old fashioned climb down the sewer, and in some cases could be as deep as 50 feet. Then you have sludge and all the other things that you have to worry about from falling in that vertical access. Then we have, and not too many people really think about this, but reducing the rescue complexity and the standby personnel requirements needed if, God forbid, something happens. So in any type of, confined space inspection, even as a drone operator, we have a visual safety observer that's constantly observing everything safety related and working with the customer, making sure that the customer understands what we're doing inside. But that's our personnel. That's not their personnel. And many times, and I've seen this on many inspections where there's like 6 or 7 emergency personnel standing around the manhole cover. And I think that's just kind of by default. By going in with the drone, we won't necessarily need that many people because nobody's really going into that hole or that manhole. And then rapid hazard identification before humans actually enter. Um, this is key because if there's a hazardous item in there, and we talk about hazards being things like collapsing soffits, stalactites that are hanging that are very sharp, water levels that may be inhabited by rodents. There's a whole slew of different ways that the safety is compromised inside of these confined spaces. So these are really, the top 4, I'll call them, inspection safety advantages by utilizing confined space drones. Okay, now we're going to get into the sexy part of what we really love about confined space, and that's the Helios 3 platform. Now, the Helios 3 platform, and I'm going to kind of segue to Taylor. Essentially, it's a collision tolerant, high intensity lighting, stabilized platform that allows us to get real time monitoring done. And when I say real time monitoring, we're streaming that video from the drone to a tablet that a subject matter expert could be viewing outside of the environment. So in just about every project that we've completed, we have a senior project engineer outside of the hole, and they're watching the video just like we're watching it on the remote controller, but they're watching it, and sometimes we'll take a cue from them to either revisit an area or maybe they want to get closer to something. But that real-time monitoring, not only somebody local, but that could be technically streamed to another location in a conference room somewhere else where somebody can review it in, a nice air-conditioned environment, not on the street. So the Helios 3. So we're taking a look at it, and essentially it's a caged UAV, a carbon fiber cage. We utilize SLAM-based LiDAR for stabilization and for high-quality point cloud deliverables. It's got a modular payload port, and you'll see that in another image. We have 4 unique forward reverse dust resistant motors that really allow the drone to, cohabitate inside this dusty and sometimes very wet environment. It's not totally waterproof, but it's dust and, water resistant, we'll say, slightly water resistant. Obviously, if water gets on the lens, you're going to see the water on the lens, but essentially the body, the structure of the vehicle itself is pretty, it's pretty rock solid. It's solid. Then we have a thermal camera that's on board as standard payload. We have a distance sensor, and you'll see the distance sensor in some of the video that we're going to share. 4K camera and this is really the heart of the system per se, is the 4K, the ability to see that video, especially when you have high capacity LED lighting on the vehicle, to be able to see in 4K resolution a confined space. You're really able to take that space and get down into the real nitty gritty detail of what it is that you're seeing. Obviously, if the lighting wasn't as good as it is, you would not see it as well. You'd have to open your shutter more, and that's something that the drone itself right now automatically will do if you put it in that mode. From an aircraft perspective, the raw dimensions of the Helios 3 is a 19-inch by 14-inch raw dimensions. Aircraft in LiDAR only weighs, let's call it 5.5 pounds before any type of payload. If we were to stick a UT payload on, we have a LiDAR payload that has SLAM technology on it. And Taylor, I'm going to let you kind of talk about the rest of the aircraft that we have here on the list because you'll get more into detail.
Yeah, really appreciate it, Frank, and thank you so much for painting a picture around the Helios 3. I'll add to it what color I can, but guys, for inspection applications and confined, specifically complex spaces, you have to have a very robust piece of hardware, and this is really it. So I would have to say that the secret sauce and the differentiation that Flyability brings into the Helios 3 is kind of how we're merging all of the different sensors, as Frank was discussing. So as soon as you're flying this drone, it's creating a three-dimensional point cloud that's merging visual information, the thermal information, and proximity sensors. And when you're combining that with the collision resistant framework, it's a real robust system that's designed to get into confined, challenging spaces, thrive in these spaces so that, it can make the mission and make it back out successfully. And ultimately, so you're not sending people in there. Um, I think one of the cool things about the Helios 3 platform, and we'll be talking about this on the next slide, is kind of how it's modular. So you can actually set this drone up for specific missions and specific inspection processes, depending on what kind of data that you're looking to get out of the asset. So if I had to summarize the drone, I would say it's a very integrated platform in that, the sensors are all driving, data collection from different types of areas. So, yeah.
Awesome. And I'll highlight that although the dimensions are 19 by 14, we like to say comfortably that minimum opening would be 23 inch by 23 inch to give the drone a little bit of flexibility to be able to get through that. The cage is flexible. So if it does happen to, bounce off the edge of the manway going into the space, it'll flex and it will definitely deter the drone from getting damaged or from damaging any of the side of the manway. So these are kind of some of the basic features, and then we'll get into more of the payload sensors as well. So here's our payload sensor. So we have the surveyor payload, which is a standard payload. Then we have the surveyor payload with the, what is it? Software version 7, Taylor?
Mm-hmm. That'll be the Rev 7, yes, sir, version.
Rev 7, which is really rock solid. It gives such a phenomenal point cloud, and it's much better than the standard payload. But if you're, starting off early in your confined space work and you want to start off with the standard sensor, that's great. We also have what's called an UT sensor, and the UT sensor is ultrasonic testing. Ultimately, inside a tank that's holding, we'll say flammable or very valuable material or structurally related, a lot of times the engineering firms want to see if any of the corrosion that we're notating is starting to get to the point where the thickness is being compromised. So we install a UT sensor right onto the Helios 3, and we can get exterior and interior thickness measurements directly from the sensor. And that thickness measurement will help identify whether something is super urgent or whether we're just meeting compliance. We have the RAD payload, and we also have the flammable gas sensor. And Taylor, let's get a little bit more detail on the RAD payload, because personally, I have not used the RAD or the flammable gas sensor payload. I believe they're relatively new.
Let me touch on those real quick. Yeah, the RAD payload specifically is designed to detect radiation. So, you had mentioned power generation, Frank. That's one of the main applications for the RAD payload is with the nuclear power plants. So customers are using these to actually fly drones into radiological areas, and they're sampling as they're flying, the radiation levels, so to speak. So combining that with the LiDAR, you can actually localize on the 3D map the different radiation levels as the drone has done its flight. The flammable gas sensor is a little bit different. I think the name explains it a little bit better, but what the flammable gas sensor is, it's That's a payload that's attachable to the drone that will obviously detect flammable gases. And the workflows with the flammable gas sensor is pretty cool because some people are using the drone they'll actually land the drone into an asset, let the gases kind of collect, and, let the sniffer do his thing before they go in and send people into these areas, kind of like how Frank had mentioned. Uh, I do want to touch on the UT. I think there's a lot of value in the UT. And, we had touched on oil and gas, tanks and things like that. And matter of fact, we have a customer that's using the UT payload to eliminate the scaffolding setups in their tanks. And it's actually saving them about $25 million a year just in scaffolding setup charges. So you can actually fly this drone into a tank, do your spot thickness checks around and get back out of that asset in probably a factor of 10 times quicker in a more safe type of environment. The survey payload is a higher resolution and accuracy LiDAR that lets you do some different functionalities that we're going to explain on a separate slide here. But if I had to summarize, it's a modular. So, the drone can do different payloads like we described, and it's configurable depending on what you have to have inspected. So we try to make it where, if you need a specific data, we can try to get that asset for you as well.
Okay.
All right. So making sense of your inspection data. So, what you guys are kind of seeing here is a video of what you would kind of see on the deliverable end. So our software, which is called Inspector, is designed to pretty much merge all of these different data streams into one kind of cohesive visual display for you. So what you can see on here is on the left, you have it looks like it was a 3D point cloud. So the 3D model that the LiDAR is generating. And there was also a visual, a demonstration going on that kind of highlights there on the right, what you're seeing with the camera. And when you look at this, you see the UT probe, on the right there. And what that UT probe is, it's generating those thickness checks. So it's pretty much coming in contact with the metal there, and then it's emitting ultrasonic sound waves to determine the actual thickness of that. And when you're thinking of having to do that by hand, I mean, you would have to lock out this asset. You'd have to clear it for people to go in there. You'd have to set up your scaffolding and or rope access, or take your drone out of the box, put it in the asset, and we'll keep your people out of there. So you can also do something called a POI on the three-dimensional model, which is a localization process for a deficit or defect in the asset. So it's almost a way that you can triangulate and localize where, different features of interest and things like that are. So
Those POIs become thumbnails right here in Inspector, which can be generated in a report and all the data that's associated with it. You also notice on the bottom left-hand corner of the video here, you're seeing both the X, Y, and the Z as far as the configuration of the drone and where it is to X, Y, and Z. We're seeing the distance as well as the height or the heading, the heading of the drone. So a lot of this information, although not truly geospatial because we're not capturing geospatial from satellites, but we are capturing spatial information from inside based on our sensors, distance sensors, and based on the point cloud calibration as far as calculating distances. So it's a pretty cool interface. When I first saw it, and our customer first saw it, I couldn't believe it, and it really made for quite the conversation afterwards, because I think most customers don't realize, they think that you're going into a space with a drone and you're just taking video. But here, what we're doing is we're taking that point cloud and giving kind of a situational awareness, as well as being able to tag these points of interest.
Well said, Frank. All right. So the deliverables, guys, You think about hardware and software, but it's really only as good as the data that, you're producing out of the space. I wanted to talk about the actual deliverables that the Helios 3 provides. And, for this to actually be a viable tool for you and your teams, the data's got to be accurate. It's got to be something that you can manipulate, and it's got to be something that you can kind of ingest and spread around the rest of the organization in terms of different applications that you're already using. So, what the drone is providing is high fidelity 3D point clouds. So there's some different file formats that you can use to export and import into different softwares and applications. And that can be anything from mapping softwares down to environmental softwares that you can use to do volumetric measurements, structural deformation measurements, and even things like geometric measurements without taking a step inside these types of assets. High resolution 4K 30 FPS camera, along with the thermals, is running concurrently, but you can actually use the software, to pull up the thermal on a quick part of your inspection and see, check for water leakage or any kind of temperature variations that might be behind there, which is really cool. And I think the best part about it is that you can extract all this data and merge all of what you're finding into reports, either like a PDF or a CSV, kind of spreadsheet. So rather than going through like hours of raw pipe footage, you can generate these actionable reports where localized defects are pinned directly to the model, to the 3D model. And, you can output these as PDFs for your team or for your inspection leaders to, kind of for them to do their job without getting back into the asset. There's compliance formats, depending on what you guys have to do for regulators, auditors, and that kind of thing. But I think the integrations is very important. We don't want to create another data silo, in the operation where everybody's got to dive into. We want to keep the data as horizontal as possible so that people can get insight into that. So if you're using the Helios 3 for, CAD files, for example, BIM platforms, we can pop those in, where you're not duplicating efforts and things like that. So to summarize, the deliverables, I think, are the actual insight that you're getting out of the asset. So absolutely.
Great analysis. So we're going to take a look at a survey payload inspection workflow. Again, it's just one of a gazillion different workflows, but we're going to run through this, and Taylor, again, will kind of describe what we're seeing.
Absolutely. So the survey payload, guys, is the higher resolution, LiDAR that comes with some more advanced processing software for the three-dimensional model. So the workflow is all about really like three core outcomes: obviously reducing risk, improving the asset visibility, and supporting decisions, right? So by accurately mapping with the survey payload, it gives you a greater degree of insight into these types of confined spaces. So you can actually do more things with it, like very precise volume measurements for things like stockpile calculations. We have a large number of Department of Transportations that use our drones for doing things like salt pile measurements and things like that. I have a customer that measures tonnage of potatoes using the survey LiDAR to get an insight in food production operations. You can use this for spatial context remediation, like we were talking about. So localizing specifically where that defect is. So think if you have 1,000-foot pipe, localizing that 1-inch crack in that 1,000 feet is extremely important. And that's the kind of stuff that the LiDAR does. And I think finally, one of the most important things with the survey grade LiDAR and kind of what that brings into very critical infrastructure inspections is you gain a very powerful way to detect change over time. So you can monitor like degradation or shifting geometry, for example, over time using Helios 3 and our survey software. So Think of it like this, like think you have a pipe with a piece of rebar sticking through it that's rusting and degrading. And you have to go in there and inspect that every 6 months to a year. You can see, using this software, like how that changes over year. So by the time you need to be proactive rather than reactive, you're ahead of the curve on it. I think the survey payload creates beautiful three-dimensional maps like with what you're seeing here. And it's a real game changer. Instead of having to send in terrestrial, LiDARs that are tripod mounted or hand carried, you're just flying the drone in and it's providing the same type of insight out of those spaces.
Great analysis.
All right. How structured reporting supports regulatory workflows. So this is a little bit different than, the survey payload, but it's really not just about having a cool 3D model. Although they look really cool, these models can actually directly support your regulatory compliant workflows. So the data kind of serves as like, your foundation for creating digital twins that you can export across the board into different file formats and things like that. That you can plug into software things for compliance purposes that really will provide a defined picture of what's actually there. So this allows you to like evaluate the assets, plan future inspections efficiently, and deploy, across the enterprise if needed, these types of inspection programs into very, very high level of criticality. And I think, I wanted to talk about the single source of truth because I think it's very important in, this space. There's always a lot of noise in inspections, competing, softwares, hardwares, everything like that. And I think it's important for you guys to consider, as you're looking in an inspection process, is have a process that's defining what the single source of truth is with everything that's going on, in your operation. So just something I thought I'd mention on that.
Okay. So we're going to talk about the 3D capture in a little bit more detail. If you notice in that last few slides, we were showing some terrestrial LiDAR and we were showing some aerial LiDAR from the outside. So if you were to, this drone will fly outside. In fact, we're doing a huge bridge inspection in New York City where we have to survey all of the piers, and it's in a confined space, but we are actually outside. So if you were to take your control points and you have, a clever surveyor, a clever contractor that can set up control points for us to measure off of or to shoot off of, and we have a base station that you could take the outside terrestrial or the inside terrestrial LiDAR, and if we have control points and outside markers, we can tie them in together. So you're kind of creating what they call in the construction industry is as an as-built. An as-built would be the equivalent of a digital twin BIM model that most architects and engineers would need to understand the existing environment down to the centimeter. If you didn't have the drone doing it, you would end up with somebody going in and an actual surveying team giving you that digital information manually versus using it, via the drone. Now, most 3D data capture fundamentally changes how inspection findings are used in remediation and engineering workflows. Instead of relying on isolated images or subjective field notes, teams gain spatial accuracy, measurable digital representations of the asset, and enabling precise localization, as Taylor said, of the defects, dimensional analysis, and condition benchmarking over time. What this does is this allows engineering teams to validate assumptions, quantify deterioration, and design targeted remediation strategies with much greater confidence. So ultimately, what we're looking at here is one of our samples where we're in a very, very old tunnel. This particular tunnel here sat in a major city in the Northeast. And you'll notice that, in fact, if we go back for a second, you'll notice on the left side of the screen, we're seeing that little turn. I'll go back to it for a second. As we're going down, we're seeing line of sight, right? And we have a repeater that's inside the tunnel to allow us that line of sight to the drone. But you'll notice right here that it takes about a 15-degree angle and it starts to make a turn. By us understanding that, it understands or helps us understand where we need to move to next if we lose a line of sight, even with the repeater. In fact, that's the repeater that you just saw there. In fact, I'll back up for a second. And you'll notice the repeater is one of the most critical. There's the repeater right there. So the repeater ultimately sits inside the space, and the ideal situation is for that repeater to have line of sight. And what that does ultimately is that creates a much stronger communication link with the drone. And if you're going down a very long corridor, such as a tunnel or a shaft, if you have line of sight of the drone, you really don't need the repeater, but the repeater will probably double, if not triple, your distance capability with that drone. But ultimately, you'll have to come back out, swap out your battery, go back in. And if anyone has any questions regarding batteries and swapping out power, we can talk about that at the end as well.
And I just want to touch off that last picture that you guys were seeing there. And it's another testament to keeping your people out of confined spaces, even using that range extender like Frank was mentioning. If that range extender wasn't there, you'd still have to create that almost that controller line of sight. So it's another functionality to keep your people out of those kinds of spaces.
And that's great. And what a lot of people don't consider, some of the newer, we'll say UAV inspection companies out there, that if you have a thorough controlled proximity stabilizing imaging and engineered lighting with the LiDAR, confined space UAV inspections produce a much more clear, repeatable inspection data set, which would significantly improve the defect detectability compared to traditional methods. It's easy to fly the drone in and just take pictures, but having some of these methodologies in place and understanding, because there are limitations in what the drone can do, more limitations on the human side, but less on the drone side. But if you follow some basic methodologies, you'll have much better defect detection, or what we like to say anomaly analysis. Okay. So we say, why Skyladder? Why Flyability? Well, Skyladder was founded in 2015. So we've been in this UAV space now for almost 11 years. And with Flyability, we bring together a powerful combination of field execution and purpose-built technology. In fact, what we're looking at right here is extremely purpose-built technology for very specific requirements that, years ago you wouldn't have thought of. What we're seeing here on the left is the standard LiDAR configuration payload. And on the right side, we're seeing the upgraded payload for the LiDAR version that is there you're seeing it on the right side. The surveying payload keeps the drone from having to meander around. And we talked about, or Taylor talked about stockpile measurements. Well, if you think about it, traditionally, stockpile measurements for a drone on the outside. So if we were working with an aggregate company, we would fly the drone and we would do traditional photogrammetry. And then with software, we would triangulate, we'd mark out with waypoints the stockpile perimeters. But if you're inside of a structure and you have no access to GPS, now you're relying solely on the drone. So by having the advanced LiDAR and the software processes in the drone, we're able to take stockpile measurements inside spaces without necessary. In fact, there's one right there without necessarily, being outside and relying on GPS capabilities. So these are just various scans right here. Here you're seeing a tunnel. Here you're seeing a manhole. Different applications would require different types of analysis, but this is accuracy from just a 0.1% drift. Um, so that is what Flyability provides, and Skyladder as a drone service provider, which we are national. We provide services to pretty much any client in the United States, as well as Lower Canada and some of the Caribbean, with regards to doing confined space inspections, because it's somewhat rare to have a really good drone service provider doing these surveys for you, because you don't just fly a traditional GPS reliable drone inside of space, although you could probably do it and get away with it a little bit, but the second it has a mind of its own, it loses GPS and it's going to crash. It also doesn't have the cage on it, so anything you touch is going to be touched by the propellers, and very, very potentially could crash in the water, crash wherever. So that is that.
Okay, thank you both for a really informative presentation. We do have some questions already, which we'll get to in a moment. And for attendees, if you have not asked a question yet, it is not too late. Just enter them now by clicking the Q&A button at the bottom of the webinar window. You can see right there on the slide with a little question mark, and just enter your questions. We've got a few here. Actually, the first question is from Kamran. By coincidence, he asks, I would like you to discuss cost comparisons of traditional inspections versus drone inspections.
Okay, so when you say cost comparisons, we'll talk about the cost to the client, because that's really ultimately, the client could be an engineering firm or it could be the asset owner. So, if you think about, let's think about a basic application. Let's call it a storage tank, and storage tank holds grain, wheat grain. All right. So some of the costs associated with that we have no control is they have to clean out the tank, obviously. The tank has to be emptied, and that would be for a manual inspection or a drone inspection. But the scaffolding, so the scaffolding that would have to be set up inside that tank, it could take anywhere from a week to a month to assemble a scaffold to be able to get a human in there, for OSHA to approve that human to be able to go in there and inspect. So you have the cost of the scaffolding, you have the cost of putting that person inside, which would be a specialist. You have the PPE equipment that would be necessary for that person. And you're looking at a process that is probably a month versus 2 days. So whatever the costs are to that asset owner for those materials, such as scaffolds, such as PPE, such as the cost of that subject matter expert inside the tank, it's pretty substantial. We see on an average about a 300% return on investment by flying it with a drone versus actual human. But the biggest benefit is the safety factor, where nobody will get hurt unless they trip on a curb outside and they knock their head on it. But inside the tank, they're not going to get hurt because the drone is inside the tank. That's probably the biggest benefit right there. So I hope that answered your question.
Okay.
Any other questions, Martin?
Yes. Next question. Here we go. Question from Pat, who asks, what do you find to be the biggest challenge with traditional confined space inspections?
Take that one.
Yeah.
And Frank, I think it's just staying out of the space is probably the biggest change. Like if you're in there, that's where the risks are increasing to the point where you need to get out of there. And I don't, and I think that, we have finally reached a point where like, you know, using a drone to be able to get into confined spaces truly is, at the high level, the core differentiator days.
Okay, next question.
All right, next question. All right, this one is from Jessica, who asked, "What are some of the capabilities of the Helios 3 software application inspector?"
I can take that one as well. So our inspector application, obviously it's kind of like an import wizard in that it's taking all of the data off the drone. You can use it as an export type of thing too, in that you're, breaking off different types of file types and moving it into your own internal softwares and integrations and things like that. But since the 3D point cloud is, uploaded in there, you can actually do things like measure. So, using our software to measure different types of dimensions and things that you need to inspect. It'll also let you do functionalities like I had discussed, where your inspect beam changes over time. For example, so you can use that software to get like a kind of a side by side comparison in terms of, how that particular defect is transforming year over year or whatever it is. And it also, kind of merges with our internal cloud services as well. So you can use that for your own organization to transmit those types of information and data files around the enterprise that you need. So it's a pretty robust set of kit.
Great. Okay, Vikram asks, "Are we able to put the data into other programs?"
Yes, absolutely. It depends on the file type and the specific application in which you're trying to, import that data into. But absolutely, we got customers that are doing that all day, every day, pretty much.
So we have
Yeah,
one
with
more.
the
Go ahead.
I'm sorry, Martin, go ahead.
No, please go ahead.
Yeah, with the file types that we can generate, you pretty much can import those into most of your, typical AutoCAD, Revit type of software platforms that allow somebody to import data from the drone and actually allow them to work in it in their own environment. So if they're in Revit or in AutoCAD, they can work on that and make adjustments, and they can actually build off of that if they're going to do remediation planning from a structural perspective. Go ahead, Martin.
Great. Okay, so we've got one more question here, but if anyone who is attending still has a question, now's your chance. Put it in the Q&A. All right, this one's from Ryan. "What's the smallest opening the Helios 3 can navigate through?"
I can take that one.
Okay.
And there are some caveats here. Like I would say, like at a the smallest diameter horizontal, uh, you know, let's say pipe or a tunnel, you could go through probably like 22 inches or greater. I recommend maybe around like 29 or 30 inches and greater, because when you're in a very, very confined space like that, your drone is creating downwash. And since you're in a cylinder, so to speak, that downwash will come on top of the drone and will create a more unstable flight than what you would experience if you were flying in a larger sized diameter.
Yeah, and to add to that, you talked about downwash. That was a good point, Taylor, because regardless of the size of the opening, when you enter a space that is dry, even a space that is wet, if it's wet on the floor or on the ground level, obviously you're not going to get a whole lot of dust and debris coming up. Sometimes you'll get a little splashing, a little drippy from the water just splashing from the downdraft. But most of the downdraft is being cycled throughout the whole space. So you're pulling, little fragments. It almost looks like dander, like dandruff. But you'll pick up all of that fragmentation, and it eventually, as you start to move on, will clear and be behind you. But as you're entering for the very first time, you're definitely going to get some, just general dust that just gets generated. The bigger the opening and the bigger the space, much less with regards to any of that standard. But if you're going into a smaller space, and I have great examples of seeing some serious amount of dust blowing around, but I'm still able to capture everything via LiDAR and video. Now, the video could be slightly obscured, but the LiDAR, and Taylor, correct me if I'm wrong, the LiDAR is not going to quite capture the dust per se. It's really going to capture what is solid that is still inside that space.
That's correct, Frank. With the exception of the very, very dusty environment, like maybe like a concrete plant or something like that. But yeah, I would consider that more of the exception than the rule.
Sure.
Got it. Okay, we got a great question that came in from Robert, and this will probably be our last question. What's the tipping point between drone confined space inspection versus human inspections? I sense it's more a situation of overall safety, complexity of the inspection, and expediency of confined space environment.
I I, I think his assumptions answered the question.
Yeah, he's hitting the nail on the head, I think.
Yes, absolutely. No, you've got it down in your assumptions. I mean, think about it. If we were just an inspection company, an engineering firm, no drone, just humans, we'd get a phone call. We'd have to do a site survey analysis of what's going on. We'd have to get some diagrams for planning purposes. We'd have to get our PPE, our team together, all the equipment, lighting, probes, all of that. Where drone service with this capability with confined space drone, we get the call, we do a site survey, but our site survey is pretty much boilerplate. We ask basic questions from the client with regards to, noxious gases, what's our opening, how many manways there are in the environment. So it's really a very expedient process to get the drone service in there and get the drone itself inside. And I'm blown away myself. I've been doing the confined space stuff now for, I guess it's about 3 or 4 years since the Helios 2 platform. But it's the direction that you want to go. And we haven't even talked about other environments, like inside commercial roofing, where you have structural components in kind of an attic type of environment in a commercial building, and you need to do a complete scan of that that enclosed environment to be able to do an addition or to be able to add any other structural components to the building itself. So it's a great way to get the job done faster, more efficient, and to get deliverables that are close to engineering grade deliverables. Technically, to call it engineering grade, we technically in the United States can't say engineering grade, but we can say close to engineering grade because we're not engineers by trade or surveyors for that matter. So I suggest if there's any applications, if there are any asset owners on this call or any engineering firms that want to do a test drive, contact me or contact Taylor. Our contact information is on the screen. If you shoot us an email, we'll get you all scheduled and we'll talk about your particular project specifically. And I'm sure at the end of the day, it's going to come out where the ROI is probably your customer may say, are you missing a zero? That's very likely what they're going to say when they see the price of going in with the drone versus doing it manually, on top of the time it's going to take. But we are exactly at our 60-minute mark. I will hang around. Taylor will hang around for a little bit. If anyone has any other questions, we'll stick around for another 2 minutes. Other than that, everyone will receive a copy of the recording link. And God bless everyone on the call. And we will see you all soon. I will just sit here for a few minutes. If there's any questions, Martin.
No, that's all the questions we have for now. And we'll be sure to follow up on any questions that come in afterwards with a direct response. And you'll get an email, everyone, with a link to the session recording within a few days. So we'd like to thank everyone for attending. If you'd like to contact us after the webinar, in addition to the email addresses, you have the websites, skyladderdrones.com and flyability.com. So we'd like to thank everyone for attending our webinar.
Thank you
Thanks
all.
so much.